Okay, let's continue. Well, this part of the code, we have already seen that before we load the data, we try to do a standard scalar. And remember, since we are dealing with the distance matrix, we do have to do that. And then we try to rebuild all the features into a data frame, and we do the k-nearest neighbor. And after that, let me see. For the k-nearest neighbor, okay, we did a one nearest neighbor, and after that, we get the result, and this is the report. So the next part is, well, if we want to try different k values to try to pick the best one, how do we do that? Of course, we can just grab this part of the code and then run that several times. So I do a one nearest neighbor, two nearest neighbors, three nearest neighbors, and then I can try from 1 to 100, for example. And this means I have to copy my own code many times. And this is ugly. You know me, I hate to copy my own code. And so how do we do that? And the answer is, how about we do a iteration? So for each round, we do one k value and then run a k-nearest neighbor and record the performance of the machine learning model. Okay, so I'm trying the k value to from 1 to 40. So if you're doing the range from 1 to 40, and remember in Python, the first value 1 is included, and then the 40, the last value, will be excluded. So in this range, we are doing from 1 to 39. Really, 40 is excluded. Okay, so and then in the body of the iteration, you see, for I in the range from 1 to 40, and each round I'm going to pick a I value, start from 1 and then 2 and then 3 all the way to 39. And for each round, I'm building a k-nearest neighbor with the k value as the I. So I'm starting from the 1 nearest neighbor. And then I'm going to train my model, make a prediction, and the next part, I want to calculate the error rate. So error rate is just how many samples are misclassified and divided by how many samples are used for the testing purpose. So error rate is just how many percentage of the samples are classified wrong. So I'm gonna, for each of the value, I'm gonna keep for each of the error rate, I'm gonna keep that in the error rate as a list. So for each round, I use I build a k-nearest neighbor model, and eventually I get the error rate, and then I just append that to the error rates as a list. Okay, so after we finish running this iteration, we will have a list of the error rates, and they are from 1 nearest neighbor to 39 nearest neighbors. And after that, we can easily do a plot. Okay, so for the y-axis, they are the error rates, and then for the x-axis, that is the k value. Okay, so if we take a look, and this is what we can find. If we want to use a very small k, like k equals 1 or 2, they are really bad. And then 3 might be a good pick, and then 4 is bad again, 5 getting better, 6, 7. 7 is another very bad pick. Okay, but if we don't want to be very specific, if we want to find a range of the possible k values, which value should I pick? So of course, the error rate is here, right? So that is probably 1% or 2%. So that is 34, 35, 36, 37. So those are a few very good k values, but they are 30-ish. Well, remember, I personally don't want to pick a very large k value because it may slow my model. Okay, so another candidate might be at this area. So at this area, we have 5% error rate, and they are still acceptable. So I have 16, 17, 18, 19. So that might be another good area I can pick the candidate k values. So based on this experiment. I would say I will pick either the k value from this area or k value from this area. So depending on more knowledge about that data set. Well, and guess what? Another thing you should do is when you do the train and test split, so which is here, right? So I use the random state as a 101. Probably you can try to use another random state and run this iteration again. And if you run this several train test split and then try to do this kind of iteration again, and then eventually you will get a better idea on which area can you pick a good k value. You want the k value to be a smaller if possible, and at the same time you also want to have a good performance of the k-nearest neighbor if possible. Okay, so the last well, for this one, actually we call that ABEL method. So why it is called ABEL method? So usually when you draw this, when you create this kind of plot, say the k value as x-axis and the arrow rate as y-axis, what you will see is, well, you start from a very high arrow rate when the k is small. However, usually the arrow rate will drop very quick, and then it will stay stable here for a while, but eventually if you pick a very high k value, it may go up again. So people say this is just like an apple. So for example, like this. Okay, this is just an apple shape. So if I want to draw, this is the body, this is the head, and then this is a person, right? So, and for this part, this is the ABEL. So people usually call that an ABEL method. And this can be used to experiment with different k values to help you pick up the best k value. So we call that ABEL method. Okay? So I will see you in the next video.